Isolated power systems are essential for patient safety in critical care areas such as surgical suites. Recertification of isolated power monitors or IPM is crucial to ensure these systems continue to function properly. Several codes and standards address the requirements for isolated power systems and their maintenance. Firstly, the National Fire Protection Association or NFPA provides comprehensive guidance through several of its standards. NFPA 99, the Healthcare Facilities Code, is a primary resource. Specifically, Section 8.4 addresses electrical systems, and Section 8.47 focuses on isolated power systems. NFPA 70E, the standard for electrical safety in the workplace, also contains relevant information. Section 230.94 discusses isolated power systems for patient care areas. NFPA 78 provides guidance on lightning protection. Secondly, the International Electrotechnical Commission or IEC also publishes relevant standards. IEC 60364-4-444 covers electrical installations of patients' locations, with Section 444.311 specifically addressing isolated power supplies. IEC 60601-1-8 pertains to medical electrical equipment, with Part 1-8 addressing general requirements, safety, and essential performance. Section 13.3 focuses on the isolation of power supply systems. Thirdly, hospital accreditation standards play a significant role. The Joint Commission or TGC, through its standard EC 2.21 on electrical systems, includes EP 14 on electrical safety, which is relevant to IPM recertification. The Accreditation Commission for Healthcare also addresses electrical safety through its standard E1. Furthermore, several other codes and standards are worth noting. ANSI or ASH or OMI ES1 covers essential electrical systems for healthcare facilities. ISO 80601-2-51 addresses medical electrical equipment, with Part 2-51 focusing on particular requirements for the basic safety and essential performance of isolated power supply systems for use in medical locations. IEE Standard 300 provides guidance on bonding of electrical equipment and systems. In addition to these codes and standards, several resources provide further guidance on IPM recertification. The Joint Commission offers guidance on recertification of IPM in surgical suites. The National Fire Protection Association provides resources on the recertification of isolated power monitors. Healthcare Facilities Management offers articles on IPM and recertification. These resources, codes, and standards provide comprehensive guidance for ensuring the safety and reliability of isolated power systems in surgical suites through proper recertification processes. The key areas addressed are requirements for testing, maintenance, and documentation of isolated power systems to minimize the risk of electrical shock and ensure continuous power supply to critical medical equipment. Compliance with these standards is essential for maintaining a safe environment for both patients and medical staff. Isolated power systems are designed to prevent electrical shock hazards in patient care areas. They do this by isolating the electrical supply from ground so that a single fault to ground will not create a dangerous current path. An isolated power monitor is used to continuously monitor the impedance to ground of the isolated power system. If the impedance falls below a certain threshold, indicating a potential fault, the IPM will alarm. This allows staff to identify and correct the problem before it can cause a shock hazard. Regular testing and maintenance of isolated power systems and IPM are essential to ensure they are functioning properly. The frequency of testing and maintenance should be in accordance with the manufacturer's recommendations and applicable codes and standards. Documentation of all testing and maintenance activities is also important. This documentation should include the date of the test, the results of the test, and any corrective actions taken. By following these guidelines, healthcare facilities can ensure that their isolated power systems are properly maintained and that patients and staff are protected from electrical shock hazards. The specific requirements for certification of IPM may vary depending on the jurisdiction and the specific type of IPM. Healthcare facilities should consult with qualified electrical professionals to ensure they are in compliance with all applicable requirements. It is also important to note that isolated power systems are not a substitute for proper grounding. All electrical equipment in patient care areas should be properly grounded in accordance with applicable codes and standards. The isolated power system provides an additional layer of protection against electrical shock hazards. The selection, installation, and maintenance of isolated power systems require specialized knowledge and expertise. Healthcare facilities should work with qualified professionals who have experience with these systems. These qualified professionals can help ensure that the system is properly designed, installed, and maintained in accordance with all applicable codes and standards. Understanding the different types of isolated power systems is also essential. There are two main types of isolated power systems, namely the ungrounded system and the impedance-grounded system. In an ungrounded system, neither conductor is intentionally grounded. In an impedance-grounded system, one conductor is grounded through an impedance. The choice of which type of system to use depends on the specific application and the risk assessment. Furthermore, proper training for staff is crucial. Healthcare staff who work in areas with isolated power systems should be trained on the purpose of the systems, how they work, and what to do in the event of an alarm. This training should be provided regularly and should be documented. In the event of an IPM alarm, staff should immediately investigate the cause of the alarm. The source of the fault should be identified and corrected as soon as possible. The IPM should be reset only after the fault has been corrected. Ignoring an IPM alarm can put patients and staff at risk of electrical shock. When investigating an IPM alarm, it is important to follow proper lockout or tagout procedures to ensure that the equipment is de-energized before any work is performed. Lockout or tagout procedures help prevent accidental energization of equipment, which could result in serious injury or death. Maintaining a safe electrical environment in healthcare facilities requires a comprehensive approach that includes proper design, installation, maintenance, training, and adherence to applicable codes and standards. Isolated power systems are an important part of this approach, but they are only one piece of the puzzle. All aspects of the electrical system must be properly maintained to ensure the safety of patients and staff. When designing an isolated power system, it is important to consider the specific needs of the healthcare facility. The size of the system should be based on the number of patient care areas that will be served. The system should also be designed to accommodate future expansion. The location of the isolated power transformer and the IPM should also be carefully considered. The transformer should be located in a clean, dry, and well-ventilated area. The IPM should be located in an area where it can be easily monitored. During the installation of an isolated power system, it is important to follow the manufacturer's instructions carefully. The system should be installed by qualified electrical professionals who have experience with these systems. After the system is installed, it should be thoroughly tested to ensure that it is functioning properly. The testing should include a ground fault test to verify that the IPM is able to detect a ground fault. Ongoing maintenance of an isolated power system is essential to ensure that it continues to function properly. The system should be inspected regularly for signs of damage or wear. The IPM should be tested periodically to verify that it is still able to detect a ground fault. Any problems that are found should be corrected promptly. Proper documentation of all maintenance activities is essential. This documentation should include the data of the inspection, the results of the inspection, and any corrective actions taken. The documentation should be kept in a safe place and should be readily available for review. Healthcare facilities should also have a written policy and procedure for the management of isolated power systems. This policy should include information on the purpose of the systems, how they work, who is responsible for their maintenance, and what to do in the event of an alarm. The policy should be reviewed and updated periodically. Isolated power systems are a critical component of the electrical safety program in healthcare facilities. By following these guidelines, healthcare facilities can ensure that their isolated power systems are properly maintained and that patients and staff are protected from electrical shock hazards. Several factors contribute to the need for recertification of isolated power monitors in surgical suites. Technology changes over time and new standards and regulations may be introduced. Recertification ensures that the IPM are up to date with the latest technological advancements and regulatory requirements. Components within the IPM can degrade or drift over time, affecting the accuracy and reliability of the monitor. Recertification involves testing and calibration to ensure that the IPM is functioning within specified tolerances. Regular use and exposure to environmental factors can also take a toll on the IPM. Recertification provides an opportunity to inspect the device for any physical damage, corrosion, or wear and tear, and to address these issues before they lead to failures. Recertification helps to identify potential problems before they escalate into more serious issues. Regular testing and maintenance can uncover hidden faults or weaknesses in the system, allowing for proactive repairs and replacements. Recertification demonstrates a commitment to patient safety and regulatory compliance. It provides evidence that the healthcare facility is taking proactive steps to ensure the safety of its patients and staff. Proper documentation of the recertification process is essential for demonstrating compliance to regulatory agencies. The process of recertification typically involves several steps, including visual inspection, electrical testing, functional testing, and calibration. Visual inspection involves checking the IPM for any signs of physical damage, corrosion, or loose connections. Electrical testing involves measuring various electrical parameters such as voltage, current, and impedance to ensure that the IPM is functioning within specified limits. Functional testing involves simulating various fault conditions to verify that the IPM is able to detect and respond appropriately. Calibration involves adjusting the IPM to ensure that it is accurately measuring the impedance of the isolated power system. The frequency of recertification depends on several factors, including the manufacturer's recommendations, the age of the IPM, and the operating environment. However, a general guideline is to recertify IPM every 1 to 3 years. The recertification should be performed by qualified personnel who have the necessary training, experience, and equipment. The personnel should be familiar with the applicable codes, standards, and manufacturer's recommendations. Following recertification, a detailed report should be generated documenting the results of the testing, calibration, and any repairs or replacements that were performed. The report should be kept on file for future reference and for demonstrating compliance to regulatory agencies. When selecting an IPM for use in a surgical suite, it is important to consider several factors, including accuracy, reliability, ease of use, and cost. The IPM should be accurate enough to detect small changes in the impedance of the isolated power system. It should also be reliable and able to operate continuously without failure. The IPM should be easy to use and understand so that healthcare staff can quickly respond to alarms. Finally, the cost of the IPM should be considered in relation to its features and performance. In addition to recertification, healthcare facilities should also implement a comprehensive maintenance program for their isolated power systems. The maintenance program should include regular inspections, testing, and cleaning of the system components. Any problems that are found should be corrected promptly. The maintenance program should be documented and the documentation should be kept on file for future reference. Healthcare facilities should also provide training to their staff on the proper use and maintenance of isolated power systems. The training should cover the purpose of the systems, how they work, what to do in the event of an alarm, and how to perform basic maintenance tasks. The training should be provided regularly and should be documented. Isolated power systems are a critical component of the electrical safety program in healthcare facilities. By implementing a comprehensive maintenance program, providing training to staff, and recertifying IPM regularly, healthcare facilities can ensure that their isolated power systems are properly maintained and that patients and staff are protected from electrical shock hazards. Furthermore, it is crucial to understand the role of bonding and grounding in conjunction with isolated power systems. Bonding refers to the practice of connecting all metallic parts of the electrical system together to create a low impedance path for fault current. Grounding refers to the practice of connecting the electrical system to the earth to provide a reference point for voltage. In an isolated power system, the grounding conductor is intentionally isolated from the equipment grounding conductor. This is done to prevent ground loops, which can cause nuisance tripping of the IPM. However, it is still important to bond all metallic parts of the electrical system together to provide a low impedance path for fault current. In the event of a fault, the fault current will flow through the bonding conductors back to the source of power. This will cause the overcurrent protective device such as a circuit breaker or fuse to trip, de-energizing the circuit and preventing a shock hazard. The size of the bonding conductors must be large enough to carry the available fault current. The size of the grounding conductor must also be large enough to provide a low impedance path for fault current. The requirements for bonding and grounding are specified in the NEC or National Electrical Code. It is important to follow the NEC requirements carefully to ensure that the electrical system is properly bonded and grounded. The NEC Article 517 addresses healthcare facilities and provides specific requirements for isolated power systems. This article covers essential electrical systems, wiring methods, grounding, and other electrical safety considerations unique to healthcare environments. The proper design, installation, and maintenance of isolated power systems in healthcare facilities require a thorough understanding of electrical engineering principles, applicable codes and standards, and the specific needs of the healthcare environment. Healthcare facilities should work with qualified electrical professionals to ensure that their electrical systems are safe and reliable.